All right, so you got a practice problem here. So you went ahead and give it a try, and you found out your answer was 1.29 meters per second. You got it. Great job. If you want some hints, stick with me here. So this is going to be a lot like the problem we first did on this page, where we had the coin or the ball rolling off that counter and landing some distance away, and we wanted to know how fast was it moving when it rolled off the counter. So the setup is going to be pretty similar. So what we see is our object is moving in both the X and the Y direction, so it's 2D motion, so I need to list both sets of variables. I also notice that as soon as they leave that cliff edge, the only thing acting on them is gravity. So there's nothing acting on them in the X direction because we're ignoring air resistance, so our acceleration is 0 in the X, negative 9.8 meters per second squared in the Y. This is a projectile motion problem. So that means these two velocities will be the same, and I will be using equation number 2. All right, so then I need to choose my coordinate system. So for this one, what you're going to want to do is I choose the ground as a height 0 and the initial position as an X equals 0. And so when we set this up, we see that initially it's at 9 meters high and at 0. So I go 0 meters and 9 meters, and at the end it lands hopefully in the water, right? Hopefully in the water at 1.75 meters, because we are going to say this is the minimum velocity required. So this is the velocity they are landing like right at the lip of that water spot here. Ideally they are going faster than that so they clear it with safe distance. Okay, so what you're going to want to do then is you want to go ahead and say, oh, hey, I want to find this V naught. So in order to find V naught X, or which is the same as V naught here, I need to know the distance divided by the time. And in this case, I have the 1.75 divided by t. So where can you find time though? If you don't know time, you got to go find it in the Y direction. Yep, so we're going to go ahead and find time in the Y direction. You notice that you have a final velocity that you don't know, so you're going to pick an equation without final velocity. So equation 2 here works. So I got y equals y naught plus v naught yt plus 1/2 ayt squared. Cross anything off that's 0 and go ahead and solve for that t just like we did before. So plug that t back in and you should be getting our 1.29 meters per second.